Morning, everybody. Today we're going to be talking about hyperbolas and graphing them, along with just classifying different portions of hyperbolas. This is the last conic section that we're going to be discussing. We haven't talked about circles, but we did talk about circles in trimester one, and it's just not as exciting as the other ones. With circles, we're pretty solid on those at this point. But hyperbolas get a little wonky, so make sure you pay attention to this one. And fair note, or just a disclaimer, I tend to mess up sometimes on these. So if you catch one, feel free to stop by Zoom and tell me about it, and I can add it to the errors that I've made. But just getting into it, I guess. But a hyperbola is any graph that will look like either this or this. Basically, it kind of looks like two parabolas, and parabolas kind of in this. So basically, it looks like two bowls stacked. And if you remember the diagram shown, this is the one that if you cut a conic section and it actually cuts into two different cones, this is what you get from it. And again, it's either going to be either perfectly opening left and right or perfectly vertical, where it's opening up and down. And it depends on the placement. And this is where it gets a little tricky. With ellipses, A is always bigger than B. In this case, A doesn't have to be bigger than B, but we have subtraction here. A is always associated with the transversal axis, which is kind of like the major axis of an oval, or sorry, an ellipse, and it tells you which direction it opens up. So if X is attached to A, it's opening left to right, and if A is attached to Y, then it's opening up and down. But it's completely possible where A is 1 and B is 1,000. So it's possible that B is bigger than A. It happens all the time. Basically just shapes the graph differently. It has nothing to do with the direction it opens up. And so just make sure you're not switching the direction. You do have to have Y in front of X unless you're switching the entirety of the plus or minus sign. Where with ellipses you can get away with it as long as the standard form is that the bigger numbers in front for that, but here it's a little different. The focus or the foci are found by a similar strategy, except it's a squared plus b squared. For ellipses, it's a squared minus b squared, and again, it's just a flipped thing. So you could think of it as just basically the opposite, where you're subtracting instead, or adding instead. And we still have covertices, we still have vertices. The covertices aren't going to be graphed, unlike ellipses. There's nothing graphing over here. But there are asymptotes. I do not mean to do that. There are asymptotes happening here. And you are going to graph these to make sure you will graph these. And it's going to help you basically graph the entire thing. When I do these, I graph 3 coordinates. I graph the center, I graph the 2 vertices, and then I basically just try to get this to look like a curve and get it close to the asymptote within the graph. And I'll show you what I mean in a second. I don't graph the foci. You could, and if MyOpenMath does ask you to do it, then you just have to find it this way. And the foci are within the bowls, so make sure that you just, it's going to be this distance away from the center and to the inside of the hyperbolas. Yeah, okay, so let's get into an example. Quick disclaimer, sorry. The formulas do switch, B over A versus A over B. it's always y minus k, x minus h. This helps with the slope, but you could just flip. You could rearrange this to make them look more similar to each other. But be careful. This is a place where I mess up quite a bit just because I'm trying to go too quickly, which you've seen me do before. But here we have an example where we have a hyperbola with center at the origin. So center is 0, 0. Focus is 3, 0. I don't know why I did that. We don't need it. And then a vertex is at negative 2, 0. Be careful. These are not attached to each other because the center's in between them. So first, you want to figure out what you can. The focus gives you C. So this is helpful because it'll help us find our co-vertices or our B value, essentially. But C is found by taking the center and finding the distance away from a focus. So 0, 0 to 3, 0, that's a distance of 3. So C is equal to 3. And then the vertex is going to be A away from the center. And 0, 0 to negative 2, 0, that's a distance of 2. So A is equal to 2. You know this is A because it's a vertex. If I said this was a co-vertex, then B would be equal to 2. So just laying that out there. And we can start throwing some stuff into the equation. If you wanted to make a quick sketch of this graph of what we have so far, we have our center, we have a vertex at negative 2, 0, and we have a focus at Mistake number 1 is on my notes. Okay, I told you. Let's erase that. So, going freehand, everybody, without the notes. Take note. This is how it's done. 0, 0, negative 2, 0 is our vertex, one of the vertices. And then the foci, one of the focus is 3, 0. And we know that it's going to be opening like this. Sorry, that should go through the vertex. We know it's going to be opening left and right. Whoop. Because it's all on the transversal axis, which is, again, similar to the major axis. And so A is going to be attached to X. In my notes, you saw me do it for a second. I graphed 0, 3 and 0, negative 2 like a noob, but I had it like this. So this would be opening vertical. That means that A would be attached to Y. So I'm going to switch it. It should be the same, essentially, but just the graph makes it look, or it depends on that A value, what it's attached to. So X squared is over A squared. So A, we said, is 2. Y squared over B squared. We don't have that yet, and we're going to say that equals 1. And we have our formula to find our focus, but we already know the focus, or the focus distance. And we don't have B, so we're going to use this to solve for B. And we know that we're going to take the square root of this. So B is equal to, C is 3, so C squared is 9. A squared is going to be 4. B is equal to the square root of 5. B squared is 5. And this should give us the same graph as what's here. Okay? So moving on, but just the way you can tell if it's opening up or down, up and down, or left and right, is based off of the alignment of these coordinates. So they're aligning horizontally. That means that your hyperbola should be opening up left and right. It's as scientific as it gets. So here we have X in front. That means that it's going to be opening up left and right. I believe all but the last are going to be opening left and right, but I'll say this each time. but it's opening left and right because x is attached to, or x is the first term, x squared is. So if y squared if y squared was in front, then it would be opening up and down. But we know it's like this, and that's just going to help us place the important coordinates. But 0, 0 is our center, so I'm going to use a different color. 0, 0. A is the distance away from a vertex, so we do need to know that. A squared is 16, so A equals 4, B equals 2. We do need to know the B value just to come up with our asymptotes. If you wanted to, you can come up with your C value. It's going to be square root of 4 squared plus 2 squared, which is the square root of 20. You can go through and figure out that it's a certain distance away, but this is just plotting the foci, so unless I ask you for it, you don't need to do this step. But good to practice that. 4 away would be here and here. So those are our two vertices, and those are the only coordinates I'm going to graph from now on. Anything else is going to be an asymptote or drawing the curve to get to the asymptote. So the asymptotes, it is the case of x minus y. So we're going to be using case A at from the notes, which is saying that y minus k equals plus or minus b over a x minus h. Again, if it's opening up and down, it's a over b. That's the only difference between the two. Y minus k is y minus 0, because the center is 0, 0. So y equals plus or minus b over a. Interesting. Have another mistake in my notes, so doing well. Like I said, I have to go through these slowly, otherwise I screw up quite a bit. Apparently I was rushing through this one. Simplify this a little bit, we get plus or minus 1/2 x. Okay. So from here, so I don't know what I did there. Okay. So from here, we're just going to graph both of these lines. This plus or minus, we've seen in the past where you get to pick. This is not a picking plus or minus. This is doing both things. So it's going to have two different asymptotes. Slope of 1/2. So over 1, up 1, over 1, up 1, over 1, up 1. And I do a dashed line just so I don't get confused. It does get very busy within this. So avoid the busyness. That's a technical term. And also me buying time while I slowly plot these points. Okay. And dot it. So from the center, from these vertices, you're going to open it just like this, but I just try to arc it and get it close to the asymptotes. And this is as that's not very good, but you're just trying to get this as professional looking as possible. I'm not going to be looking for any coordinates. You might need some in MyOpenMath, but if you do, then you just plug in a couple coordinates on the sides. My guess is it won't make you, but I haven't made that assignment yet, so I'll stay tuned for that one. Okay, so moving through this. So find the center of this. We're gonna graph this basically, using all of our information. The transverse axis equation is just going to be y equals a number or x equals a number, and that just depends on if our coordinates are lying horizontally or vertically, and through what line. But we will get to that in a second. Our center, first it's going to be left and right, opening up like that. So we're going to have y equals b our transverse equation. And y equals, it needs to go through the center, so y equals -3 will be our transverse axis equation. But 2, -3 is our center. Our vertices, we'll get those in a second. Foci and asymptotes, we'll get all of that in a second. But let's start pulling this apart. A equals 2, B equals 3, C equals, it does ask for the foci, so we do need to actually have our C value. It is square root of a squared plus b squared, which is 4 plus 9, or 13. And square root of 13 is very roughly about 3.5. I haven't checked this, but that's as close as I'm going to get to accuracy, so I'm going to call that good. But that could be 3.1, and I could be wrong. But 3.5 seems like a good estimate. All right, so plotting our center to -3, and our foci are 3.5-ish away. So 1, 2, 3.5. 1, 2, 3.5. And A is 2 away, so we are running left. We're opening left and right, just like that. And that is 2. Okay. Again, it gets super messy in here, so you're try to label them if you can, but the center vertices are the next foci are in at the outer edges of your transverse axis. And I guess we should label these. So you're going to say 2. I'm going to be lazy about this and say plus or minus root 13. You might have to write these separately. So one is 2 plus root 13. The other one is 2 minus root 13. The asymptotes, it's opening just like case of 1a. So it's going to be y minus k plus or minus b over a x minus h in parentheses. And we are good to go. So y minus k is y plus 3. This is y minus k as well, so you just have to take this entire binomial and swap it out. Plus or minus b is 3, a is 2. Another mistake, catching them. Okay, good thing I did it first. Doesn't always happen, everybody. Sometimes I do it without going through it a practice round. Okay, so 3 over 2 times x minus 2 is going to be our equation. I like to position, actually, it doesn't really matter. This part, the x minus 2, y plus 3, just tells you it's going to go through the center. You don't have to have it in terms of y equals mx plus b. It kind of makes it more confusing if you do. So here we need just to move over 2, up 3, over 2, that looks messy, over 2, up 3, over 2, up 3, over 2, up 3, over 2, down 3, over 2, down 3, and good there. Over 2, up 3, over 2, up 3, 3. Isn't it so much fun watching another person graph? I love it. Just go to YouTube and watch so many people graph. It's so cool. Coolest thing you could ever do on a June morning, afternoon, night, whatever you're doing. Hopefully staying safe out there. I see you. Okay. All right, so we have our asymptotes, and then we are going to, that was terrible. Let's try that again. So you're trying to get it close to that asymptote as it should, and get close to that asymptote as it should, and you have your hyperbola. Again, follow those rules. The way I screwed up on my notes, I put 9/4 here. Don't just put those straight up from those values. These are a and b squared, not those aren't a and b. These aren't a squared and b squared. These are a over b or b over a. So make sure you take the square root, or you're using these values when you're plugging stuff in. There's a lot of stuff going on here, so just go slowly. Make sure you're plugging in the correct stuff. All right, last one. Final boss of hyperbolas. You have to complete the square, and you're going to have to do it for two things. Also identifying which is which can be an issue if you're not careful. The thing I look for is what's being subtracted out of the two things that are being squared. If neither are being subtracted and they're on the same side, you're working with an ellipse or a circle. Both of those could happen. So there's three things that could happen if both x and y are being squared. It's an ellipse, circle, or hyperbola. Parabolas, there's only one thing being squared, so it's not an issue. But the only one that has alternating plus or minus for the square terms is the hyperbola. So if one of the terms is being subtracted and the other one's not, we are working with a hyperbola. Important to be able to identify based off of standard form. Something that you would be asked to do in other versions of this class. So our major axis, or our transversal axis, is going to be running vertically because y has the positive term. Or y squared has the positive term, x squared has the negative term. So this is the first one where it's opening up and down. And what I do is I just get all of the y's together, all of the x's together, similar to how I explain this with the ellipse problem, but again, whole nother animal. Next, you want to factor out that negative out of both of these terms, so it's going to be minus x squared plus 2x. And since we're here, I'm just going to factor out the 4 as well. And you are going to take half of this and square it. Half of this is negative 2. That squared is positive 4. Again, you are not just adding 4 to the left-hand side, though. You're adding 4 times 4. So over here, you're adding 16. You were adding 16 over here, but it's just kind of protected, and we have 4 sets of this thing. Over here, half of 2 is 1. 1 squared is 1. So we're going to add 1 inside of the parentheses, but we're not really adding here. We're subtracting a positive 1. So we're going to subtract 1 and then simplify this over here. Negative 11 minus 1 is negative 12 plus 16. We have 4 on the right-hand side. Over here we have 4 y minus 2 squared minus x plus 1 squared, and it equals 4. To be able to put it into graphing form, or our vertex, the HK form that we've been using, we need to divide by 4. We want this to equal 1, which we'll put it like this. You don't technically have to have that denominator. I put it there because it makes it super obvious what a squared is. Let's see if I made I made another mistake, everybody. Got it. Okay. I put b equals 4 here. B squared equals 4. That means b equals 2. A equals 1. And this is, again, running vertically because it's attached to a, or attached to y. All right, let's throw everything out on here. Careful, this is h. It's attached to x. Negative 1 horizontally, positive 2 vertically. I didn't screw up on that one, everybody. Now I'm second guessing everything, but we're almost there. It does say to graph that. Okay. So the transverse axis is going to be a vertical line going through this So x equals -1 is our transverse axis. Our vertices are going to be 1 away vertically from this coordinate, so 1 is here. I'm going to do a different color just to keep it. This looks tight. That's not a different color enough. Let's go yellow. Give it some pop. Okay, so those coordinates, can't really see it there. The vertices, can't see it very well at all. Let's go black. -1, 3, and -1, 1 are our two vertices. Foci, we need to find out our C value. C is the square root of 1 squared plus 2 squared, which is square root of 5. So our foci is going to be -1, comma 2 plus or minus root 5. You know it's 2 plus or minus root 5 because again it's running vertically. Plus or minus root 5 is about a little over 2, so we're going to go a little over 2 away from our center, which is blue. It's probably a little off, but whatever. Our asymptotes, let's do red on those. It is y minus k, so y minus 2 equals, and we're switching it, plus or minus a over b, so 1 over 2. Messed up again on that. Okay, again, I screw up a lot on this section, so I'm surprised I've caught it this many times. Ooh, woof. X plus 1. Okay. Okay, so we're going to run 2 over up 1, 2 over up 1, 2 over up 1. I'm going to call that good. 2 over down 1, 2 over down 1, 2 over down 1. Call that good. Reflect it or not. Do whatever. It's your life. It looks like it needs to go right there. Okay. Can't use my cheater method of turning my paper. But it should run like that. Yellow is our vertex, or our vertices. I'm going to use purple. And again, we're just going to make it run. Get it close to the red. Doesn't look curved enough. It should be curved. But again, my dexterity right now is not at its primest value. But there we go. There's some vocab on that purple sheet, but this is our last of the hyperbola, or last of the conic sections. But thanks for sticking with me. I'm sure this was a long one. I haven't checked the time on it, but it probably went long. First, they just take a while. Also, it's hard when your teacher's catching mistakes throughout his entire lesson. So sorry about that. If you have any questions, check with me on Zoom. But I hope to see you on the next one. See ya.